Hello everyone. So before I solve question for today, I wanted to tell you about our study plan that has been going on right now. So as I mentioned last week that we'll be running this plan initially for 30 days and later we'll extend it based on your interest. So this has been going on. Now we are in the second week of this study plan. So if you want to study with other students who have been following this plan, you can join our Telegram group and we'll have the link in the description, so you can study through that. So for each day we are sending the study plan, and in the evening there is a question, and as I mentioned at the end of the week we'll also have a quiz. So you can use any of the resources that you are currently using for studying, and this plan will just give you a more structured day and more structured goals for each day. So now let's move on to today's question. So this question, it is from friction, as we covered mechanics last week. So I wanted to cover this question, and here, basically this question is from GATE. So it says a wedge M and a block N are subjected to forces P and Q as shown in the figure. If force P is sufficiently large, then the block N can be raised. So here we have this wedge M and the block N. These are arranged in this manner, and there are these forces P and Q that are applied here on these two. And if this force P, if it is sufficiently large, then in that case it will try to move in the forward direction, and the result of that would be that this block N will move in the upward direction, and that's what it is saying. Then it says the weights of the wedge and the block are negligible compared to the forces P and Q. So these weights we have to neglect because the forces P and Q are comparatively much larger. The coefficient of friction along the inclined surface between the wedge and the block is 0.2. So on this surface between block and wedge, this mu is 0.2. All other surfaces are frictionless. So surface 1 and surface 3, it is saying these are frictionless. Wedge angle is 30 degrees. So this angle here is 30 degrees. The limiting force P in terms of Q required for impending motion of block N to just move it in the upward direction. So it is saying that what will be that impending force at which the block will just move. So it is talking about the limiting condition, and it is saying that it is given as P is equal to AQ. So in the original question it is alpha, here also it is alpha, and we have to find out the value of this coefficient alpha, and it is saying round it off to 1 decimal place. So let's see how can we solve this. So in this type of question we have more than one surface. Here we have more than one surface. So in that case it is better to separate these surfaces and draw the free body diagram separately. So first we have the block and we also have the wedge. So here this force P is acting on this block, this force Q is acting. Now if we take one by one, so let's say we are drawing the free body diagram for the block. So there is this force Q. Now from other surfaces, so from this surface there will be a reaction force. So we can say there will be a normal force, let's say N dash, and on this interface between M and N there will be friction. So friction will be in the forward direction. So how did I come up with that? So this block M, with the help of this force P, if it moves in the forward direction, then on this surface the block N will be moving in the backward direction relative to this block M. So friction opposes the movement. So if it is going to move in the backward direction, so on this surface friction will act in the forward direction, and the opposite of that will be there for the wedge. So here friction will be there in the backward direction. Now the normal force will be there. So normal force is perpendicular to this surface. So let's say that is N. So if here it is N, then on the wedge also we'll have the same normal force N. So apart from this, any other force is there? So I think these are all the forces because they have told these other two surfaces are frictionless. So there is no friction there. Now this angle here is 30 degree. This angle is also 30 degree. Now with the help of horizontal and vertical equilibrium, we can solve the remaining question. So if we draw a perpendicular here, then the angle between this normal force and perpendicular, it comes out as 30 degrees. So here, if we see the angle for this friction force between horizontal and friction force, then this angle is also 30 degrees. It is directly coming from here. This surface is inclined at 30 degrees. So from horizontal, friction is also acting at 30 degrees. So if this angle is 30, then the angle between friction and normal force, this angle would be 60 degree. And then between perpendicular, this angle here, I mean this total angle showed with red line is again 90 degrees. So if this part is 60 degree, then the remaining here again would be 30 degree. So that is the logic how we are reaching at this 30 degree angle. You can try with this triangle also. So anyway, you can figure out this angle. Now we have this angle. So we have to find a relation between normal force and this friction force as well as the force Q. So we can see force Q is acting in the vertical direction. So if we take horizontal equilibrium for this free body diagram, then there will be no force Q. So because of that, we will consider the vertical equilibrium. And let's say we are taking downward as positive. So we'll have force Q acting in the downward direction. Now we have this force F or the friction force inclined at 30 degree. So it will also have a component in the downward direction, and that would be F sine 30, and its horizontal component would be F cos 30. So we'll be using the vertical component. So Q plus F sine 30 minus the vertical component of the force N. So N cos 30 is equal to 0 as there is no other force. Now we know friction, it is given as mu N. N is the normal force. Here we are denoting N as N itself in the question. So we can write F is equal to 0.2 N. The value of mu was given as 0.2. So if we solve this, we have Q plus 0.2 N sine 30 is 1 by 2 minus N times cos 30 is root 3 by 2 equal to 0. So from here we have Q is equal to N times, or N by 2 we can do common. So we'll have root 3 minus 0.2, and we know the value of square root of 3, that is 1.732 minus 0.2. So it becomes 1.532, and dividing it by 2 we'll have 0.766. So here it becomes Q is equal to 0.766 N. So this is the relation between Q and N. So this is what we got with this vertical equilibrium. Now let's come to the wedge part. So on this wedge, again we can write an equilibrium equation, but here because this force P is horizontal, so we will be considering the horizontal equilibrium. Summation of horizontal forces equal to 0, and let's say we are taking in the rightward direction as positive. So we will have, so again we'll need the angles here. So friction is acting at 30 degree from horizontal, and this normal force, because this earlier angle here was 30 degree, so here also between perpendicular and normal, this angle would be 30 degree. So in the horizontal direction, the component of normal force would be N sine 30, and for the friction, the component would be F cos 30, and P is acting in the negative X direction, so minus P is equal to 0. So solving this, we can write P is equal to N sine 30, or N times 1 by 2 plus F cos 30. So F, as we wrote earlier, 0.2 N times cos 30 is root 3 by 2. So we have P is equal to, we can take n by 2 as common, so we will have 1 plus 0.2 times square root of 3. Now we have this relation between P and N, but in the question we are interested in the relation between P and Q. So we have the relation between Q and N, and we have the relation between P and N. So from here we can substitute this value of N as Q upon 0.766. So we'll have P is equal to Q upon 2 times 0.766 and 1 plus 0.2 times square root of 3. So after this we can just use the calculator to solve this, and we get P as 0.878 Q, and in the question it was asked to round it off to one decimal place, so we can say P is equal to 0.9 Q. That is the required answer. I mean, the value of alpha from here is 0.9. So this is what was asked in the question, and to solve this kind of question, for friction related question, it would be always better that you divide the parts in these free body diagrams, and after that it is just writing these equilibrium equations. So if you are not sure vertical or horizontal equation we have to write, you can write both the equations and see. But we would be interested in particular variables, so you can focus on that. Like in this question, as I said, we were interested in the value of Q, so we took the vertical equilibrium. Similarly, in this second part, in the wedge part, we were interested in value of P, so we wrote the horizontal equilibrium, because if we wrote the vertical equilibrium here, then we will not get any relation for P. So that way you can solve these questions.